All right. Now, let's go over all the details of these next couple days for us.
You're not really giving them some quiet time.
What?
We should
No, you're
probably
fine.
just have
Okay.
a study.
All right. Nope.
Not only that.
Stop. All right. Book check-ins for everyone else in this room is this Friday. Book check-in. I know we just did a book check last week just to make sure everyone had the right book number. Seniors weren't missing theirs. This Friday you're going to check in books. All late work from me. All late work is due by Friday. So if you have anything in the grade book that has LIs, blanks, bless you, anything like that, it's due by Friday this week or else it stays a permanent 0 from then on out. Okay, so make sure you're checking your grade book. That if you owe me something, you're getting that turned in. What?
Can we get some homework back?
Friday. Because the book has to be checked in by Friday, so all late work has to be done by Friday.
Mr. Work, can we get some of our homework back soon?
So, yep. Okay. Other things. Semester test for us is a week from tomorrow. We will start reviewing it on Wednesday this week. And what I mean by reviewing is that we're going to be doing, we'll be taking the second half of each day and doing like a couple problems at a time. I think the semester test for us came out to be like maybe 16 problems, something like that.
So will
total.
this stuff be on the test?
So, yes, this stuff will be on the test because it's just the last part. It's super easy once you see
I
it.
feel like it shouldn't be because like the seniors don't have
We want to do vectors in 5 days.
Okay.
This is on the semester test. The stuff we do out throughout this week will be on there.
Do we not have a test over this?
Oh, yeah.
No, it's just we add these couple problems on the back. It's pretty straightforward if you take notes from me. Okay? So, the big thing here is that semester practice guide. I'll probably hand them out maybe as early as tomorrow, but we won't start reviewing until tomorrow or Wednesday.
Wednesday?
We'll do about 3 to 4 problems a day leading up,
Get closer.
and then we'll take our semester test next Tuesday.
So when's
Tuesday,
our test on
Wednesday.
this chapter? when's our test on chapter 6?
It's on the semester.
What? That doesn't count though, wasn't it?
Okay. All right. Other things. Let me hand out some other stuff that you guys asked.
Shut it.
Mr. Work, can you count me on points if I draw the triangle
Amanda, continue. How far away can I stop you? Oh, Amanda, I'm popular now. Your sister followed me.
Okay. All right. Papers I'm handing right now. You can make corrections on these. You can do whatever you need to. Test scores were online as of last Friday. You can, if you want to make fixes, or I should say, if you want to retake, just talk to me throughout the week, and we'll get you a scheduled time to retake.
A video with first
Yeah. Now, here's the other issue with that is that one of those days I'll probably be gone, but the sub will probably have the video for me. I have a funeral, so.
I'm sorry to hear that word.
So at some point this week I'll have a video for you guys to watch. I'll have everything you need. I'll have the review. It'll go through all the problems. I'll try to put it on the put it up so you can actually easily see it. If I have a little bit of time and I know which day it is ahead of time, I'll probably just record myself on the marker board like I normally would, so it looks a little bit better than some of those PowerPoints I've done previously. But yeah, so this week we need to wrap up the chapter that we're on. We only have a few sections to do here, which are really straightforward and really simple, before next year, where we can continue on with the basic stuff where we left off at. Okay, are we ready to go? All right, here we go. Let's talk about this. Let's talk about what a vector is.
Vectors. It's like physics vectors or something.
Yeah, it's physics vectors.
So will this be like great pressure for me?
Yep, it should be. Also known as a vector quantity.
It's motion with the duration.
Yeah. So here's the idea. A vector for me is some unit of length.
But not me.
So it's a geometric figure.
Wait, Justin.
Call him Justin.
All right. So it is a geometric figure that contains a magnitude and a direction.
No, new pasta file.
And direction. Okay, now what that is, okay, is to me it looks like a ray in geometry class. So this is a vector. This is what I normally would see. Now, in geometry, rays, you know, they had a direction,
And magnitude.
but the problem is, we talked about that they went on forever. What we're talking about is that this actually represents kind of like a segment almost. It's not really a ray.
I thought it was like
This is giving a direction that it's heading,
But it ends there?
but it ends there. So it actually does have some form of distance
And
to it.
magnitude.
And that distance is represented by the word magnitude.
Velocity.
And magnitude.
Don't forget magnitude.
Alright, now, magnitude is the actual number, it's the actual distance. Okay, so here's what we're going to talk about, how to actually find the distance and direction that we're going. So, let me give you an example here. So, what they typically will do on a problem, they'll do something like this.
0.4.
B is 2 times 7, okay? Alright, they'll tip. Okay, so for my vector, it has an I and a j component. How this works, how you actually find it, you always take the terminal side, so this is the x and y component, right? And this is the x and y component, right? You subtract the numbers from the terminal, and you subtract the initial. So for my x component, you're going to take x minus x, and that's going to go in front of the I number on your vector. So we'll call this vector v. So when you subtract this, you're going to go, not negative 2, but you're going to take 2 minus 0.
Oh wait, how do you decide that?
So it's always terminal minus initial.
Oh, okay.
So 2 minus 0, that number is going to go in front of I. Now I is like, it's a cursive letter, sorry it looks like a J, but it's supposed to be, kind of an italicized
Okay, just
I.
make the curve go the other way.
Alright, there you go. And then for the j component, you take the y numbers and you subtract those, so 7 minus the 4. And that'll be the j component. And so what my vector has, like an actual numbers themselves, this is what it is.
2j.
It's 2i
3j.
plus 3j. Okay? So that's the vector itself. That's traditionally the notation for how they write a vector. It's got an I and a j component, it's kind of like an x and a y. If you were to actually look at the drawing of this thing, and actually like on a Cartesian coordinate plane, 0, 4, 1, 2, 3, 4, so here's A. B is over 2, 7, 1, 2, 1, 2, 3, 4, 5, 6, 7. Here's B. And this is the vector, because we started here, we ended at B, that was the terminal side, so the arrow goes towards B, it gave me a direction. Okay, so that's the rough sketch of it. But the idea is that this is the part that represents it. And what these numbers are, like the 2 and the 3, that's your x number and your y number. So if you actually look like at a triangle, this is your 2 number, where it comes from for the I, and this number is the j component, that's the 3 going up and down. That's where those numbers come from. So if you're really not good at remembering which order you subtract, you could, in theory, draw the triangle, like on an actual coordinate graph, and then just count, like over and count up, and that gives you your I and j component anyway. So that's kind of like 2 ways to do it. I think the fail-safe is just where you end minus where you started. Just subtract it. Okay. It's just so that we can get away from the coordinate plane setup that we had in Algebra 1, because for magnitude, it's not a ray. A lot of people, when they see the picture, it's an actual distance. It's a stick, and this concept is what we used when we did the problems where we had an airplane fly a certain direction and then it changed directions and then flew somewhere else. This type of setup can actually give you the same answers on those problems, but it'll make it a little bit easier to look at and understand. Like, it gives you a different way to solve those types of problems. Okay, did everyone understand how I came up with the I and j component? Again, I and j components for a vector is basically the horizontal versus vertical in change. But again, the definition of a vector is magnitude and direction. That's contained on a geometric figure. Now, what we're going to be looking at is 2 different things. Number 1, we're looking at a direction, right? It's going a certain tilt, the way it's drawn. Yeah, that's an angle. We're eventually, like tomorrow, we're going to look at how to find angles. That's one of our topics we're going to look at tomorrow. Today, we're going to look at magnitude, and we're going to look at slope. Those are the two things I want to look at. Slope technically gives you a direction. It does give you a direction in theory. So how do you find slope in normal algebra 2? Or algebra, I should say. What was the formula for slope? What do you guys remember? That was the linear equation.
Delta
what-
y minus, or delta y over delta x.
Okay, good. Delta y over delta x. Now, don't get me wrong, Riley, you were on it because you were saying y equals mx plus b. M is the part we were looking for. Yeah? All right. Now, so delta y over delta x. This means you change the change in y's over the change in x's. We already know these numbers. This is the beauty of it. We already took the difference in the y's. That was my 3. We already took the difference in x's. That was the 2. The slope is actually given to you in this form.
But backwards.
So, yeah, it's just you take the y number on the top and the x number on the bottom. The reason why is it's rise.
Is that kind of like who
Overrun.
gets to the house first in division?
What?
In division, we gotta, who gets to the house first?
Yeah, it's kind of the same concept. So.
I don't see any houses though.
Great, all right. But rise and run, rise is always y numbers, run's always x numbers, how far you're going over. Now, what this number is, since this number is positive, knowing that it's 3 over 2, it's a positive number, it's going up to the right. So, like when you look at the picture, it is going up to the right, because it was a positive number. If slope was negative, you're going down. So you can get kind of a rough sense of scale, like where this thing is actually being drawn. And it doesn't matter where you translate it from. Because this picture can be, what I mean by translate, they could slide this picture anywhere else.
Like into Spanish?
And the idea is that, I'm talking about this, that you could move these pictures to different spots, but you follow the same pattern. You go over 2, up 3, that type of thing, so over 2, up 3, and this gives you a sense for where we could draw these pictures. Vectors can be placed anywhere on a graph as long as it has the same direction, same slope basically, and same magnitude, which is the actual length of it. Now, how do you find length? That's where you actually solve for the x on a right triangle. You actually have to do Pythagorean theorem and actually solve the distance out. Does that make sense? Now, the good news is
No, it's just 2 squared, 3 squared.
exactly, because we already know the numbers. We did that math earlier. So it's just 2 squared plus 3 squared equals the x squared, and you solve for x. And that gives you your magnitude, the length of the stick. So the length of the magnitude. So x squared equals the 2 squared plus 3 squared, and you take the square root of it. So this is 4 plus 9, and we're taking the square root of it. So this turns out to be my length. Now, how you actually define magnitude? This is how you do it. They use 2 bars, but it's got double bars. Double bars means magnitude, and you use the Pythagorean theorem to actually find it. And so the rough drawing actually helped me out. So this turned out to be the square root of what? 12? 13? 13? 4 plus 9 is 13? Okay. Questions at all about what magnitude is?
No.
Now, why we're finding these parts? Why we're actually doing this? This concept of magnitude actually can help you find angles for what this thing is actually making with the x-axis. So if we were to move this to a certain spot and put it right on the origin, now you can find angles it makes with the x-axis, like the terminal side and the initial side when we draw in center position. And so that's something we're going to look at more tomorrow, is actually like the distances there. The goal today was just to talk about what a vector is, which you guys are seeing the example of it, how to find, rise and run, how to find the actual length of it. But the goal today is to also look at the basic properties of vectors themselves. So, does everyone have the basic notes down so far?
Yes.
Okay. Does anyone still need it?
I think we're gonna get used to it.
Okay, we're moving on.
Amanda's
They already
favorite.
tried it on.
Basic no.
All right. Again, this stuff is on your semester test, whether you can find it or not. So hopefully you're paying attention to it.
Oh, yeah.
Yeah, I got
Never seen that video?
All right.
The x is minus
Okay, vector operations. Okay, first one, how we can do vector operations like this. You can actually take a vector and you can multiply it by some what they call a constant. They use the number k. I don't know why they don't use c, but they take some number and they multiply it on your vector, whatever your vector is. Sometimes vectors, they use the cursive letter or the italicized letter, and they put a little arrow saying that hey, v is the actual vector itself. If you're going to take a constant times a vector, let's say that the constant here in this case is a 5, and your vector v, whatever that vector is, let's say it's the 2i plus 3j like we were using earlier.
You
Okay.
just distribute.
Yeah, basically you just take the 5 and take it times both items. So you're taking 5 times the i component,
10 I's.
and you're going to take the 5 times the j component. And what this is, you know, you guys are saying the numbers, 10i, 15j. Okay, you guys are finding out those numbers. Now, what this means, if you're to actually draw it, this picture, wherever that vector is going,
It got
Okay.
5 times bigger.
5 times longer, yeah. So this is over 2 up 3. So this is my normal vector v. Well, what this 5 vector v stands for, it's 5 times longer. And so what that means is eventually we're
Stretching
hitting
it out.
10, 15 down the road.
So that vector's
This spot down here is 10, 15. That's basically what it's saying. It's got the same slope the whole entire time.
It's just kind of like.
It just, yeah, just basically
And
it's
then can
extending
you like
lines.
do 1/3 of it too?
Yeah, I mean, you can do any numbers you want, and
And now
you
we'll
can-
make it smaller.
and it makes it smaller, but they're going the
Can we
same
move the
direction,
graph?
it's just moving. We can shift it right and left, but that's stuff we're gonna do next, okay? Alright,
Like when you throw a negative and it flips it, do we do
yeah,
that?
it goes opposite way.
I don't like doing that. I had one of those on math.
Okay, hey, we good with constants? Okay, second thing, other than, you know, doing what they call scalar operations, scalar multiplication, okay? In fact, let me write that, it's called scalar multipliers.
Amanda, do you have that down? Yeah.
Alright, second thing here is how
Scalar
to add
quantities, I remember that
vectors.
one.
So it's vector addition.
Mr. Ward, why is it a K for constant if constants are C?
I know, that's the same
Consonant
part.
is also a K though. K is a consonant, so it's.
Alright, so,
It's okay.
You could also use the letter.
hey, so vector addition. So if I give you two vectors, let's go vector v is 2i plus 3j. Okay, alright. So there's vector v, vector w is a 5i minus 4j. Now what these stand for, these stand for two different vectors. So if we were to actually draw these, okay, 2 over 2 up 3, so this is vector v. That's what it looks like, this is vector v.
Like Mr.
Vector w is going over 5, down 4. So it's going this direction.
Whoa.
But when you add these two together, so when they write this, when you add vectors, you're actually putting one on the back of the other one, and you're drawing it to a new location. So this is vector v, this is vector w. But what they're doing, when they actually say this, you're actually dragging it to a new location. You're taking this thing here, and you're putting it right on the back of vector v. Because it's basically, when they add, they're doing this. They're going this vector first, plus, after you get done with that vector, then you can just continue on the other path or the other one that you just said you're adding to it.
So you can't switch around the order you're adding.
Adding, you technically can, it will still get you to the same answer. Because if you go w plus v, you'd go w first,
It's gonna get you.
and then you go to plus v second, and it would still get you to the same spot. It just, the picture looks a little bit different, but you'll still get the same answer though. Now, the actual numbers we're gonna
It
get,
becomes an issue when you need to find the angle.
yeah, when you have,
You can't do the.
5, 6 issues.
okay, when you actually find this answer, and I'll go through the numbers here in a second, it's pretty straightforward.
That's a right angle.
The answer you're gonna get, is this. This is vector v plus w. So when you actually add them together, this vector right here is the one you're looking for.
That's
the
the
one in red.
hypotenuse.
Okay, yes, the hypotenuse, if it's a right angle, I don't know
That
if
is
it
a
will
right
be.
angle.
We can figure that out here in a minute, if it is or not. But how you actually add them together is pretty simple. You just add the I components, add the j components. That's all you do. So my new vector would be this
7i.
one. 7i
Minus I, or minus J.
minus 1j, or just put minus j, that's fine. this vector, what you're finding here, is this thing right here. That's what it represents. You're going over 7, down 1. So this spot right here is 7, -1. That's the spot you just landed at. I can find the length of it, you can find what it adds or subtracts to, but subtraction is a little bit different. Subtraction, this is the part that, yeah, you're distributing the negative, but it's making everything go backwards. So let me just show you this. So,
Is it
All
my
right.
fault?
alright.
I don't know, is it?
I actually like that one. That one's actually kind of interesting. This
This
stuff's pretty
I played
interesting,
the,
Mr. Woods.
I played the fifth.
Is it J?
I think it's the.
Oh.
Just a turn. Alright. So let's go the same ones. V, but now we're gonna subtract W. So what this one is doing, it's drawing the same vector V that you started with.
B minus.
So 1, 2, 1, 2, 3. Alright, so we're going the same vector from the beginning. That's vector V. But when they go minus W, typically when we did addition, when we added W on, this is what it did. From here, it went the same thing. It went over 5, down 4, whatever that was. And this was vector W that we had. Okay, that was vector W. But this case, we're subtracting W. So instead of adding,
going backwards.
what minus W is, it's going this direction for W. So it's basically distributing a negative sign over W and going backwards the other way. So what negative W means, it means this. So vector V is 2i plus 3j. And vector W is the 5i minus 4j, but what we're doing is we're putting a negative in front of it.
So plus the 4
So,
and
yeah,
minus.
so we're gonna distribute the negative through. So what we're gonna have is negative 5i plus 4j, and what this number is right here, that's what you're doing right here. You're going back 5, up 4, and that's where those numbers come from. That's why this is negative W. And so your final answer for what I'm doing when I'm actually subtracting vectors together, because I'm going V minus W, it's looking for this vector
Right there. The
right
hypotenuse.
there. It's looking for this. This is V minus
We
W.
can find out what angle. it is.
It's the actual new vector connecting beginning to end. And so if you actually subtract these numbers together, this is negative W, because we changed all the numbers negative. And you're actually combining these now. So if you have both of these, you have negative W and you have V, you can just add the two numbers together. Because you don't need to distribute another negative sign. You already have a negative W. So if you've already made the numbers negative, just add them together. So this new spot is going to be negative 3i, because I added these two together. And then you add these, and this will be 7j. And this, that number right there represents this thing, V minus W. I should be over 3 spots, up 7. And so this spot here is,
Good question.
Oh, I
Back.
didn't actually very good.
How does that work when it should be the same distance as the other one?
no, I'm saying it is. I mean, because we're going, this direction goes over that way. This one's going back. It doesn't have to be, negative 7 comma 1. It's just, we're going back the same W. So it's traveling up this direction. And you're going at the same numbers
It's the
from there.
coordinates of that point where they meet.
Yeah.
Same angle.
Oh.
When you hook them up, it'd be
On
one
my desk.
straight.
So we'll continue tomorrow. Alright, for everyone else, that's it for today. Hopefully you have both written down. We're going to talk about angles tomorrow.
Everything I do.
Time to start.
Dane does all these tests.
What are you doing, Mike?
You
In
can.
the advance, Emmy told me that he was just crossing things out in his pen.
That 39 slide thing that you're supposed to have. That you didn't do.
Hey, Sam, when you get ready, just let me know. I want
Reese,
that.
does she get mad if you're not done with that?
Oh yeah, she just.
I have like that.
If you have to finish with what?
Yes.
I had like 3 pages done, and you get
For English or what?
I have like 20
She was
done.
so mad.